Good morning, everybody. I hope everybody can hear me. So to contact me, you have three options. You can turn on your video, or you can unmute yourself, or you can use chat to type me. If you cannot hear me, please let me know somehow, and then we'll try to fix that. If you hear me and see me just fine, then you don't need to do anything at this point. So I'm assuming it's working okay. I hope everybody is doing well. I hope everybody is safe and healthy. Your families, your friends, your loved ones. We're having really tough and unprecedented times. Hopefully, we'll make it through. As I said in the class announcements, if you have any concerns about the rest of the class, please don't hesitate to contact me. I'll be very understanding in this time. I have to be. I want to mention about the remaining of the semester a little. So as I posted on Canvas, the second test will be next week, and it will be through WebAssign. I think it's not 100% certain yet. You will have one day to take the test, for example, from 8 a.m. to 5 p.m., let's say next Wednesday. Again, it's not certain yet. And then you'll be able to take the test anytime you want. Probably you will have 50 minutes or 1 hour, and you'll take the test through WebAssign. And there will still be partial credit. I think I will be able to grade it partially. Other than that, yeah, since I found out the test is getting pushed back to next week yesterday, I didn't make any plans for different plans for this class. I was planning on getting questions from you all and going over some practice problems, but I found out that the test is going to be next week. But still, I want to do a review. I want to solve some practice problems, and then on Wednesday and Thursday, I plan to move to 11.2, and then the test is going to be next week. As I said, I will do more review sessions probably on Friday and Monday. And as soon as I learn when the test is going to be, I will let you all know. But one thing we know for sure, it's going to be next week. And sometimes we will do the class through Zoom as we're doing now, and sometimes I will use Panopto. Panopto is even easier than it's easier to use than Zoom. Sometimes I will upload some lecture videos on Panopto, and you'll be able to see them on Canvas. And I'll always let you all know in advance if we're doing Zoom or Panopto. So just follow the announcements I make on Canvas. You should be fine. If somebody has a question, yeah, test. The test is going to be next week. Oh, okay. Okay, I got you. Yeah, it's working. So any other questions? If you want to test if the chat is working, you're welcome to do that. and these sections are being saved. So you'll be, I will send you all a link to watch the session later. That's a good question. I don't think the ID will be the same, but I'm gonna send out the ID before the meeting if you're having trouble. Did anybody else have issues with logging into Zoom? I mean, logging into this meeting? It should be on Canvas, the Zoom section, and once you click on the meeting, this screen should pop up. But yeah, if you're having trouble with it, I'll send the ID in advance. I can do that. I'm assuming there are no other questions. Does anybody want to ask me to solve any particular problems from the study guide, or I'll just pick some and work them out, and let's see how we can follow the solutions. One D, okay. Okay, so then I'm starting with 1D. I'm gonna rotate the laptop. By the way, I'm in a classroom right now. I'm gonna rotate my laptop to the desktop screen, and you'll be able to follow the question over there. But still, I will be able to see my laptop screen, which means I will be able to see your question. So if you have any questions at some point, please let me know using chat or just talk. It's really up to you. And then I'll stop and answer your questions, okay? So let's start with 1D. Okay, I'm gonna write a little, and then I'm gonna ask you all how you can see it. Let's see. So 1D is the integral of ln of x over x squared dx from 1 to infinity. So check. Can everybody see the screen fine? If you're having troubles with reading or anything else, please let me know. I can move it to the left or right, or up or down. I feel like it shows up okay. Okay. So this is an improper integral. Remember the improper integrals. There are two types. The first type involving infinity. If there's infinity, if one of the bounds is infinity, then that's the first type of improper integral. Or if there's a discontinuity point, for example, if you have x plus 1 in the denominator, and if -1 is on the integrals interval, that's a discontinuity point, and that's called the second type of improper integrals. So this is the first one. The way we handle the first type of improper integrals, we replace infinity with any variable, and that variable should go to infinity in the limit. In other words, this can be rewritten as let me write it this way first. So that's the question, and here's the solution. So limit as t goes to infinity, from 1 to t ln of x over x squared dx. So then we need to integrate ln of x over x squared. I don't see any questions, so I'm assuming everybody can see my solution. So how can we integrate ln of x over x squared? We can try to rewrite this integral as ln of x times x to the power of -2 dx. The reason why I did that, now it looks like a product, so we can try to use integration by parts. So let's recall the integration by parts. From 7.1, it's u dv equals uv minus v du. And how do we choose u and v? Remember, there was a word lap-t, logarithmic, arc functions, polynomials, trig functions, and exponential functions. So in our problem, we have natural log of x, which is L, and x to the power of -2p. So we need to call ln of x u, and everything else dv. So if you call n of x u, then you will have 1 over x dx du, and the entire derivative of x to the power of -2 is going to be x to the power of -1 over -1. So which is going to be our v. Now let's plug uv and v du in our integration by parts formula. U times v, which is going to be ln of x times x to the power of -1 over -1 from 1 to t, and then v du is going to be from 1 to t x to the power of -1 over -1 1 over x dx. Any questions so far? Let me stop for a bit and make sure if everybody can see the screen fine. I'm assuming no questions. So then let's keep going. Let's try to rewrite. Let's see. I think we have a question. Okay, that's how we deal with improper integrals. So infinity cannot be bound of integral. Okay, if you're given the infinity as one of the boundaries of the integral, it's actually not solvable. So to handle that, we're replacing infinity with a variable, and then that variable goes to infinity, which takes care of the infinity on the boundary. So that's a general approach to first type of improper integrals, the integrals that have infinity on the boundaries. If you if you check the lecture notes, I think we did 4 or 5 examples of the first type of improper integrals. And in all problems, our first step is replacing infinity with a variable t, u, k, it doesn't matter. And that variable should go to limit. And you should work out the integral, assuming that the both boundaries are finite numbers. And then once you work out the integral, which what we're doing right now, you're gonna replace t with infinity since t goes to infinity. No problem. Any other questions? Okay, I'll keep going and I'll make sure I'll make sure to look at the screen very often to see if you have any questions. So what was our next step? The next step will be rewriting these expressions because it seems a little messy. What we can do is, how about if you rewrite this guy as ln of x to the power of -1 is over x. In other words, x on the bottom. It's going to be from 1 to t. And what about this guy? I think this guy is going to be negative times negative. They're going to have positive from 1 to t, x to the power of -1 over x. Let's think about that. X to the power of -1 over x. I think we will have 1 over x times 1 over x, which is going to give us x to the power of -2. This is what I mean. This is how I obtained this. So we had x to the power of -1 times 1 over x, which means x to the power of -1 times x to the power of -1, which is x to the power of -2. So that's how we obtain this x to the power of -2 here. I hope it's clear. So we have negative ln of x over x from 1 to t, and then x to the power of -2 from 1 to t. So let's take care of them separately. I want to call this guy A and this guy B. So let's start with A. So if we plot t for x and then 1, ln of t over t minus ln of 1 minus, I think we need to put one more minus, minus negative ln of 1 over 1. And this is going to be plus, but it doesn't matter because ln of 1 is 0, so this is gone. What about ln of t over t as t goes to infinity? This will be ln of infinity over infinity, which is an indeterminate form, which means we need to use L'Hopital's rule. So, and the way the L'Hopital's rule works is if you have infinity over infinity or 0 over 0, to work that limit out, you can differentiate the top of the fraction and the bottom of the fraction separately. So in this case, I'm calling it LH. ln of t, if you differentiate that, you would have 1 over t. And if you differentiate t, you would have 1. Let me write it more clear. So it's a little small. So we'll have, as t goes to infinity, negative 1 over t over 1. If you plug infinity for t, you will have negative 1 over infinity, which is going to be 0. So it turns out a is 0. So let me give a break and make sure if anybody has questions. Any questions so far? Okay, then I think we're doing good. So we took care of A. Now let's try to work out B. B, which is right here. So we need to integrate x to the power of negative 2, and it will be from 1 to t as t goes to infinity. Okay. So how can we integrate x to the power of negative 2? We need to use the basic power rule. So x to the power of negative 1 means 1 over x. So this is pretty much what we have. Negative 1 over x from 1 to t. So as t goes to infinity, this guy is going to be 0. Negative, negative is going to be a plus. We'll have positive 1. So it turns out b is 1. And the final answer is going to be it was a plus b will be 0 plus 1, which is 1. It turns out this integral is convergent. So I think somebody has a question. Let's see. Some exams from, okay, I'm about to do that, but does anybody have any questions about 1D? I'm assuming not. Okay. By the way, right after this class, I have office hour, and I will hold my office hour through Zoom as well. So if you wanna ask more questions, you're very welcome to join office hour meeting, and I will keep working out problems. So I'm assuming 1D was okay. So I'm moving to number 9. And again, don't worry about taking notes right now, because I will send the link to the session. So you'll be able to rewatch the session. You'll be able to pause, play, rewind. So it will be easier for you to take notes. So number 9, let's see what we have. Okay, I put some explicit solutions from number 9 on Canvas. Please see that, it's in the file section. I think I posted the solutions to B, C, H, J, K, and O. By the way, you don't need to worry about 9G. 9G is super long. I don't really expect such a long problem in the test, because when you set up the partial fractions for 9G, you'll see there will be 4 unknowns. 4 unknowns is too much. So I would say don't worry about 9G. Maybe we can work on 9F. I don't think I solved this problem. From 0 to 1, x cubed minus 4x minus 10 over x squared minus x minus 6 dx. Okay, let's start. So so this is a partial fraction problem, which is section 7.4, which is the integration technique on rational expressions. If we have a rational expression to integrate, if we have 2 polynomials on the top and bottom, then you might want to try to use the partial fraction techniques that we learned in section 7.4. So when we do partial fractions, the very first question we should ask ourselves is, do we need long division? Okay, do we need to do long division in this problem? We need to do long division because if you check the degree of top, which is 3, and the degree of bottom, which is 2, the degree of top is greater than degree of bottom, so we need to do long division. So I'm gonna work out the long division here. Because degree of top is greater than degree of bottom. So x cubed minus 4x minus 10 is divided by x squared minus x minus 6. So the way the long division works, you always go by the highest order terms. So we have x cubed and x squared. Let's say the first iteration, x cubed over x squared is x. So we need to put it here. It's going to be the first term of the quotient. And then x times this guy. which is going to be x cubed minus x squared minus 6x. So we need to subtract x cubed minus x squared minus 6x from x cubed minus 4x minus 10. So if you do that, x cubes will be gone. You'll have positive x squared minus 4x plus 6x plus 2x and minus 10. Any questions so far? Okay, I think we're good. So do we need to do one more step in long division, or should we stop? So we have the remainder x squared plus 2x minus 10, and the divisor is x squared minus x minus 6. So they have the same degree. It means we gotta keep going. You gotta keep going until you get a remainder that has less degree than divisor. So the second iteration is gonna be x squared over x squared, which is 1, which means we'll basically subtract exactly the same expression as the divisor. So it will be x squares will be gone, 2x plus x, 3x minus 10 plus 6 is going to be minus 4. So what does that mean? It means this expression right here can be rewritten as from 0 to 1. By the way, I didn't put the 1 on the quotient. X plus 1, the quotient, plus 3x minus 4, the remainder, over the same denominator. Let me stop here and make sure if you all have any questions. Any questions so far? Okay, then let me continue. So let's double check our long division real quick. So x cubed over x squared was x times x squared minus x minus 6 is x cubed minus x squared minus 6x. This is what we're subtracting from x cubed minus 4x minus 10. X cubes will be gone. That's how it's supposed to be. The highest order term should get canceled. We have minus minus x squared, positive x squared, negative 4x plus 6x, gonna give us 2x, and then we have minus 10. So it will be x squared minus 2x minus 10. And then if you divide it by x squared over x squared, which is 1, so we'll subtract exactly the same term from x squared plus 2x minus 10, which is going to give us 3x minus 4. And then the way we rewrite the rational expression is the quotient plus remainder over the same denominator. So we have two terms. From 0 to 1, x plus 1 dx, which is going to be straightforward to solve. And then from 0 to 1, 3x minus 4 over x squared minus x minus 6. X squared minus x minus 6 dx, yeah. So again, let's call them A, maybe not A this time, K and L, because we're going to use A, B, C for the partial fractions. So K will be x squared over 2 plus x from 0 to 1, 1 over 2 plus 1 minus 0 over 2 plus 0, which is going to give us 3/2. And what about L? For L, we got to use partial fractions. Can we factor x squared minus x minus 6? I think we can. So 3x minus 4, x squared minus x minus 6 can be rewritten as 3x minus 4 over, this is the partial fractions part. X squared minus x minus 6 can be factored as x minus 3 times x plus 2. So we'll have a over x minus 3 plus b over x plus 2. So we need to figure out what a and b are. We need to combine the denominators. 3x minus 4 is going to be equal to, let me show that step. 3x minus 4, x minus 3 times x plus 2 equals a times x plus 2 plus b times x minus 3 over x minus 3 times x plus 2. So we don't need to worry about the denominators. So pretty much what we have is 3x minus 4 equals a times x plus 2 plus b times x minus 3. And remember how to solve this equation for a and b. You can plug any values you wish for x. And always it makes more sense to plug in the numbers that make each factor equal to 0. In this case, it will be -2. 3 times -2 minus 4 will be equal to b times -2 minus 3. And then this is going to give you -6, -10 equals -5b, which means b is 2. And x is going to be 3. Then 3 times 3 minus 4. I'm going to zoom in. I know I'm writing smaller. I'm going to zoom in and you'll see it more clear. My bad. A times 3 plus 2. 3 minus 3 is going to be 0, so we don't need to worry about b, which is going to be 5 equals 5a. A is 1. So let me zoom in the partial fraction step. And let me give a break and make sure if anybody has any questions. Any questions regarding the partial fractions on how we find a and b? Okay, I'm assuming nobody has any questions. I just want to show this more clearly. The denominators are gone. So then let's rewrite L. it will be a over x minus 3 plus b over x plus 2 which is going to be the natural log of x minus 3 from 0 to 1, and then 2 times natural log of x plus 2 in the absolute value from 0 to 1. So now we're done with integration. We need to plug the boundaries. And then 1 minus 3 is going to be negative 2, but it's in the absolute value. It's going to be positive 2. I'll show it in the next step. This is going to be negative 3. And 2 times natural log of 1 plus 2, which is 3, plus the natural log of 2. So we'll have 3 ln of 2 plus 3 ln of 3 as L. And the final answer is going to be K plus L, which is going to be 3 halves plus 3 ln of 2 plus 3 ln of 3. Let's double check if the plug-in process is correct. If you plug in 1, you will have ln of 2. If you plug in 0, you will have ln of 3. If you plug in 1 for x, I think you will have ln of 3 again. If you plug in 0 for x, it's going to be ln of 2. If you distribute 2 over these parentheses, you will have 2 ln of 3 and 2 ln of 2. If you add them up, L will turn out to be 3 ln of 2 plus 3 ln of 3. And we were looking for K plus L, and we know that K is 3 halves. I think the final answer is going to be K plus L, which is this guy. I think I have a question. Let's see. Did I add? Oh yeah, you're right. Yeah. Yeah, why did I add that? Should have subtracted. So I think this will change. This will also change. So then we'll have, let's see. Negative ln of 2 and negative ln of 3. So let's double check. If you plug 1 ln of 2, if you plug 0 ln of 3, we need to subtract. And then if you plug 1 for x, you will have ln of 3. If you plug 0 for x, you will have ln of 2. If you distribute 2 over the parentheses, you will have negative 2 ln of 2, which is going to give us negative ln of 2. And then negative ln of 3. Yeah, thank you for catching that mistake. I think it seems correct now. Any questions? Oh, yeah. negative ln of 3 plus 2 ln of 3. Yeah, it's going to give us positive ln of 3. You're right. Yeah, thank you. Let me zoom out a little so you can see the whole process. Yeah, that's the entire question. Any questions on this problem? Okay, then let me do one more problem from number 9. I'm going to do something I haven't posted on Canvas. I'm going to do P. It's not quite long. Okay, then let's start. I think it seems clear. So we have root x plus 1 minus root x in the denominator, a rational, a radical expression. And as I always say, the square roots give us trouble when we integrate. So we want to get rid of them as soon as possible. And I would say the easiest way to get rid of the radical expressions in this problem is multiplying the top and bottom by its conjugate. This is what the conjugate means. Conjugate of root a plus root b is root a minus root b. So basically, it's the same terms with the opposite sign. And when you multiply them out, using the identity a minus b times a plus b, it actually gives you root a squared minus root b squared, which is a minus b. So let's try that here. I think we'll have root x plus 1 plus root x over, again, root x plus 1 minus root x times root x plus 1 plus root x is going to be the square roots will be gone. So we'll have x plus 1 minus x, pretty much. Which is just 1 on the denominator. Couldn't have been better. So we got rid of the denominator. So we can split these two terms. I'm gonna call A and B again. A is gonna be, I think we will need U sub to solve A. So we'll have root U du, which is gonna be U to the power of 1/2 du, which is gonna be U to the power of 3/2 over 3/2, which means 2/3 U to the power of 3/2, which means 2/3 x plus 1 to the power of 3/2, which means, I think this is what it means. You don't need to go further than this. And B, it's going to be more straightforward because you won't need a U sub. It will be root x, which can be rewritten as x to the power of 1/2. It's going to be x to the power of 3/2 over 3/2, and 2/3 x to the power of 3/2. So it turns out A plus B is 2/3 times x plus 1 to the power of 3/2 plus 2/3 times x to the power of 3/2. And it's an indefinite integral, so we just put the integration constant. It should be it. And let me zoom out so you can see the whole solution. So, does anybody have any questions on this problem?
Where am I?
Okay, I'm assuming no questions, and I think we ran out of time, so yeah, I'm gonna end this meeting.
Leave him alone.
I'm gonna end this meeting.
Hey, look, if you're gonna come in here, look, you gotta turn it down, okay? Or go back up there. But turn it down. Thank you.
If you have more questions, you can join the office hour meeting, which I will start in 7 minutes. I hope this was a helpful section. You know, this was our first try, except for yesterday with a few people. So please let me know if you have any suggestions to improve the efficiency of the session, what I should do to do it more clear. Please don't hesitate to contact me. And thank you for attending to the meeting. And I hope everybody has a good day. Bye.